All right, so welcome classes. In this video, I'm going to show you how to go over some of the code to understand sampling distributions, as well as some of the population parameters. So let's first share the screen. Sorry, I got some barking dogs in the background. Let's go. Here is the code available to you on Canvas that you can kind of work with and modify. I'm just going to help you walk through it. First thing you do is load our data. Okay, so if I run this, if you're forgetting how to load data into R, I recommend going back to that explore dataset activity and tinker there. Obviously, if you have any questions, come to me, or Mr. Cleary, or ChatGPT. Anyway, so I'm reading the CSV. If I click on this here, it's going to show up like this. We haven't really looked at data in this kind of raw form, but if I do this and make it a tibble, right, this line of code, now it puts it into the format that Tidyverse recognizes a little bit better. If I want to view the whole thing, obviously, I can go to view data set and see all the Pokemon. If you don't like Pokemon, I mean, where do we go from here? But hopefully you know a little bit about Pokemon and that they basically fight each other and they have all these different characteristics, perfect for a data set. And note that this data set has about 800 entries, which is right in the middle of that 500 to 1,000 entries that we recommended. So the first thing we're going to do is try to understand the population. In this case, we're talking about the population from the entire Pokemon data set. And the first thing I'm going to do is find the population proportion. Okay, and I'm going to do that with the table Pokemon legendary. And in this case, I chose a field that only has two options, true or false. Okay, in which case there's 65 true, 65 legendary Pokemon. Legendary means like they're the GOAT, and 735 that are not, which means 65 divided by a total of 800, about 8.1213%. Okay, so that's our population parameter for the percent of Pokemon that are legendary. I want to make a quick note here that, you know, we've had a field that was like one or two values. If I wanted, for instance, I could use another categorical variable like type 1 and find the percentage of Pokemon that are water or bug or something like that. Right now I'm doing it easy. Here's just these two values, but I could do any categorical variable and have it be, for instance, here we have like what. Let's just go ahead and so table Pokemon type 1. Like, let's say I just wanted to find all electric and it would be electric or other. Anyway, that's how we find our population proportion. Okay. Now let's talk about our numerical variable for which we'll do the sampling distribution of the sample mean. Okay, the first thing I'm going to do is find the mean and standard deviation of this field. You can see it's around 69.26, and our standard deviation is 25.53. I should know we're talking about the HP, which is like how much health a Pokemon has. And when you're battling, when the health goes down to 0, you're out. Okay, so Pokemon with higher HP are generally better. Anyway, now I want to go through, make a histogram. Now you've seen actually the code for this. Let's run this where we say Pokemon data, pipe it through to ggplot, say what we're plotting, the aesthetic is HP, and we want it to be a histogram, right? We've seen this. And if I run this, here's how it looks. Obviously skewed to the right, but other than that, pretty normal looking, okay? I've added some lines of code that I think are helpful to know about. These geom-v lines are vertical lines that I'm going to add to the plot, okay? The first vertical line is going to be at the x, it's going to intersect the x-axis at the mean of the Pokemon HP, so around 69. So it's the mean of the population parameter. Oh, I'm sorry, that's going to be over here. And then I'm going to add two more vertical lines, one that's one standard deviation plus the mean, and one that's one standard deviation minus the mean. I'm sorry, I should put this over here. Those are the geom-v lines, geom vertical lines. Okay, you can see I've also put like their color and size. Feel free to play around with those as you will. I've also added geom text, which is labels. I'll work through that line of code. It basically says, it's easier to actually go over this one for the mean. I'm going to put it at x of the mean of HP. So again, 69. And then the y is going to be up here at 150. Okay, you can see my cursor following through. And I'm going to have the word mean. And then for the standard deviation ones, I have the x-intercept is equal to the mean plus one standard deviation. So again, that would be like 95-ish. Okay. And then again, you see oh, sorry. And then again, you see 150. So it's going to again go over here. Okay. So if I run all of this code, don't worry about the warnings. Here we have the mean and minus one standard deviation plus one standard deviation with these lines. Cool. So now we have some information about the population. Of course, in your answer, you should be describing the shape and identifying some other useful metrics. Now let's go to the sampling distribution. We're going to start with the sample mean, okay? So what I want to do is I want to have 1,000 samples with a sample size of 30. Obviously, I'm inheriting 30 from the central limit theorem, which is something you'll probably talk about when you're referencing sample sizes in your project. So I'm making these objects called n samples and sample size equal to 1,030 respectively. And what I'm going to do is I'm going to collect a bunch of sample means, and I'm going to collect that in an empty vector, which you can kind of think of as an empty list. So right now I click on it and there's nothing in there. It's null. Okay. But I'm going to add 1,000 of them through this kind of complex chunk of code called a for loop. Now, what a for loop does is it iterates code, or it iterates some functions over a set period of time. In this case, iteration is I, and we're going to start at 1, and the colon you'll see is going to go to 1,000 n samples, right, that we defined earlier. So it's going to do it once, it's going to do it twice, it's going to do it 3 times, it's going to do it up to 1,000 times. And what is it doing? Well, first it's picking a sample, and then it's finding the mean. So first, this line of code within this for loop bracket is sampling of sample size 30. 30 values from this Pokemon HP, right? Here's the whole thing. And then here, and by the way, replacement's true, so there's independence. If I run it, this becomes my sample, 30 random numbers selected from here. I can find the mean of these 30, 70.33. That's my mean for one sample. And what I'm doing with appending, you might know this word from English, is I'm adding it to this empty vector. So right here, what I'm saying is append this mean value to the sample means vector. And then what it's actually doing is replacing the old vector. And it's going to continue doing that, adding that and replacing the old vector, such that when I do this, now I have one number. Let's run it again. I run this sample. In my new sample, my mean is 68.8. I run this. Now I have 2 numbers, okay? And if I do it again, of course, I have 3 numbers, okay? I'm going to clear this again, but now I'm going to run the for loop, and it's going to do that 1,000 times. Already done. And look over here in the environment tab, you'll see 1,000 different means, okay? Let's click on it. And you can see they're roughly in the same vicinity, okay? Now, again, here, what I'm doing is this is code that you've seen before, right? We're taking the tibble of the sample means and we're plotting it on a histogram. Here it is, looks normal. Wonder what led to that. And now what I've done again is added some lines and some text, again using the mean for the x-intercept for these vertical lines, along with some standard deviation. The other thing I had to change here was the y, because, and actually, let's make sure that this text shows up 110. Let's see. Oops. Oops. Sorry, for some reason showing up as sample props. We don't want that. Let's go through this one more time. Hopefully that is everything. Here we go. All right, and here we are. Okay, so we have the mean, the standard deviation, etc. Now, one thing you might want to do, right, when we talk about finding the mean and standard deviation of the sampling distribution, we could do the mean of the sample means, 69.10. And if we find the mean of the population parameter, Pokemon data, HP, really close, right? Similarly, if we find the standard deviation of the Pokemon data HP divided by the square root of 30, right? As we sort of identified, we get 4.6619. But what if we just take the standard deviation of the entire sampling distribution? Oops. Again, really close, right? So you're going to be asked to do that too, is compare our standard deviations and our means, right? Using the equations, which are more theoretical, and the actual standard deviation from this for loop in which we actually create a sampling distribution. Now we're going to do the ones for proportions. We're again going to find 1,000 samples, but this time our sample size is going to be 200. Why? Well, we already talked about the population proportion was 0.08125. Now, if we multiply that by 30, which is what we had for the means, obviously we get a really small number and smaller than 10. So we don't want to do that, but let's do 200. Cool, we're greater than 10. Then if we do 1 minus this, now we passed the success failure condition. Both of them are greater than or equal to 10. Again, I'm going to make an empty vector for sample proportions, right? Oops. Now, this is a little different because in raw values, the legendary field was true, false. And we can't necessarily add or subtract that very easily. So what I'm going to do is I'm going to reclassify these, okay? There are two ways to do it. Let me go over both. This one is really good if you only have two values, or a few values rather, in which you say, okay, I want to mutate the legendary field. I want to recode it, recoding legendary so that true is equal to 1 and false is equal to 0. If I run this and I go back to this data set, cool. We have our 1s and our 0s, okay? Another option that I just want to mention, especially if you have quite a few categories, is the if-else, okay? It's the same mutate function. Here I'm doing this actually for a different field. I'll start with that. Remember I talked about like that type 1 field. Let's say I wanted to just make them 1 if they were grass or water. Okay, let's do that. If type 1 is equal to water, make it 1. For everything else, make it 0. Okay, so now I have this new field, type 1 example. Let's look at 1s. All of these 1s are corresponding to water Pokemon. And then when we go over here, we should see 0s. Okay, we could do this again for this. We could say mutate, make it legendary. If legendary is equal to true, make it 1 or make it 0. right now, these are false and trues. If I run this, that they reverted because I reran this read CSV file code. Anyway, if I run this, now I'll go back. Oops, I missed a Y here. Let me just reintroduce so that all the work I did is kind of erased. And now let's run this code again. You'll see back to legendary 1, 0. And what the 1, 0 is really useful for is now when I average that, I'm going to get a proportion. So for instance, if I have a sample of 3 and one of them is legendary and I add 1 plus 0 plus 0 and find the mean of that, it's 0.33, which is a proportion like we agree obviously makes sense. Here we go back to the for loop. For every iteration from 1 to 1000, right, as n samples. Again, we're sampling, in this case, sample size is 200 of the legendary Pokemon. We're doing it with replacement, so it's independent, okay? So let's do this here. Sample, a lot of 0 and 1s, and then we find the mean of that. We're gonna add to this sample prop, so now we have 1 proportion, 0.09. Let's do it again. Why don't we? 0.09, 0.06, right? And so we're going to do this 1,000 times. Let's clear sample props and run this. It's going to do it 1,000 times, of course. Now, if I look at sample props, it's got 1,000 different proportions. Same deal with this code chunk, right? I have my x-intercepts at the means, and then I'm sorry, I have vertical lines, 1 intercepting the x at the mean of the sample proportions, and then 2, 1 plus 1 standard deviation, 1 minus 1 standard deviation. It's all coded in the same way. If I run this, okay, this one looks a little less normal, I'll admit for sure. It's probably because we have such a low proportion. But let's go ahead and find, if we find the standard deviation of this sampling distribution for sample proportions, we get this. What happens if we do the square root of 0.08125 times 1 minus 0.08125 divided by 30, divided by 200. We get pretty darn close there, okay? That's for the standard deviation. And by the way, a little easier, the sample proportions, 0.08075, and obviously that is close to remember if we did table Pokemon and then we did 65 by 735, 65 by 800, 0.08125, right? So obviously this 0.0807 is very close to 0.08125. Okay, so that's all of the code you really need. You might have some questions, especially about reclassifying, and of course, come to us if you do. But hopefully this code is sufficient to help you as you explore your own data set. So enjoy. Thanks for watching. Don't forget to hit the subscribe button. Just kidding. I will never check that.